Good morning, everybody. I'm Andrew Elfish. Welcome to the Innovate Everyday panel series from Genetec. I'm the Vice President of Marketing at Genetec, and I want to welcome you to today, panel number 5, the last in our series that we've been broadcasting over the summer. Today, we're actually going to take a look at a very, very interesting topic related to data science and its use in the physical security industry. We're going to be discussing how our users and our partners can take more value from physical security systems during this pandemic period through the use of data insights derived from the practice of data science. And we're going to look at ways that it can improve performance, drive greater safety, and greater situational awareness in the facilities and organizations that take advantage of this cutting-edge technology. I'm joined today by two big thinkers at Genetec who are definitely on the cutting edge of data science, Dr. Florian Matusik and Dr. Sean Lawler. Why don't you guys come on out? Hello, good afternoon. Hello, Sean, good morning, Sean. Lucky you, it's not 7:30 for you, Florian. Gentlemen, why don't we start by introducing yourselves to the audience and giving them a picture of who you are and what you do at Genetec. And we'll start with the furthest from Montreal. Florian, why don't you kick us off?
All right. So if I have a minute or so, I will tell you the whole story. So I'm Florian. I'm the product group director for video analytics at Genetec. I'm based out of Vienna. And how did I get here? Well, I've been in this field for about 19 years now, and I started my studies at the Technical University in Vienna. I did my bachelor's degree in media computer science and switched my master's to computer graphics and digital image processing because I found it super exciting to work in this field that tries to make computers see. So we called it computer vision, trying to figure out what's happening in the video. I remember one of my first internships was in a German company that developed glasses to make blind people see. And that's super exciting. They had glasses with a camera, with a small PC, and with some electrodes, they were stimulating the eye. So blind people could see a 3x3 pixel screen in their brain, which is, wow, it's totally amazing. And in my internship, I was processing the image and trying to figure out what's the most important information in this image so you can display that on a 3x3 pixel screen. So super exciting application. So that's why I went into my master's. I did my master's also in Vienna. Later on, I did my PhD in information processing science in Oulu, University of Oulu in Finland. The topic was about privacy protection and video surveillance using computer vision. So that was my academic track. But in the meantime, after my studies, I went to Estonia to work for Skype. As back then we called it video expert, when having video calls was still something special. But quit there to start a. It's still special, to be honest. But back then it was really tough. It just didn't work. So I was at Skype in the beginning because they had the headquarters for R&D in Estonia, but left them to go back to Austria and found a company with two other guys we called Kiwi Security, which basically its aim was to automate video surveillance. So to analyze all the video in video surveillance, the thing that we call today video analytics, and that was 14 years ago, and that led me here. And now I'm the product group director for video analytics at Genetec.
That's great. And Kiwi Security is a part of Genetec now.
Right. Absolutely.
Yes. We can say it. All right. Thanks very much, Florian, for that introduction. I can't wait to get into talking about computer vision, automation, and all of that great stuff. Dr. Sean Lawler, who was up very early this morning, welcome to the webinar. Maybe you can introduce yourself to our audience.
Hi, everyone. I'm Sean. I'm the lead data scientist at Genetec. My role here is essentially to deal with all of the metadata collected within Genetec and try and bring additional value out of it. So I run a small team with a variety of expertise, ranging from doctorates in physics, number theory and real math, and mine is in engineering. I got into this space because, and this is a running joke I tell everyone, but it's the truth, I really didn't do very well in physics. I didn't like optics, so I never followed computer vision, which is like a big hot topic now, and it's great, and it can bring a ton of value, but I focused more on the metadata side. So taking this either text or raw information after it's been processed and had some value extracted out of it to bring additional value on top of it in layers. I did all of my studies actually at McGill. Received my PhD, God, 4 years ago. Time flies fast. But I worked under a computer networks group, and my research was in traffic estimation and detection patterns. So I'm trying to identify the flow of traffic through a city using actually some data from Genetec back in the day, as well as open source data related to Bluetooth identification and LPR, trying to measure movement of traffic and patterns and detect groups of cars traveling together, things like that. So some fun applications. Now my team ranges from responsibility in core features that'll be coming in the next releases of Security Center to some internal tools that are helped with our support department, which I think we'll get into a little bit later. But we have a broad scope, but it's a lot of fun.
Yeah, that's great. And it seems like both of you complement each other very well. You know, Florian with your expertise in computer vision, Sean with your expertise in metadata. It's a nice little microcosm of Genetec we have right here in the webinar. So guys, thank you for the introduction. I know from being in the sort of more media relations side, public relations side of Genetec, there's a ton of coverage out there around artificial intelligence. I don't think you can go to a trade show, well, you definitely can't go to a trade show right now, but if you were to go to a trade show last year, you couldn't throw a stone without having some camera manufacturer or device manufacturer talking about AI. It was like this magic thing they injected into everything. I think mostly into advertising and less into technology. But that said, maybe we can start with giving our audience a bit of a baseline on what people actually mean when they're talking about artificial intelligence. And I'm going to ask both of you to respond, but Sean, why don't you kick us off here and give us a picture of what AI really is?
So AI in reality is a research field. It encompasses a ton of things that are all being passed off right now as more than they are. So machine learning, teaching a machine to identify tasks without being pre-programmed in advance and teaching it how to identify new patterns and things like that is a subsection of the AI research field. AI is being used as the catch-all term these days for solutions that are really just machine learning, or maybe one or two machine learning solutions combined together to provide a nifty insight. That's not necessarily a bad thing. The problem is that the messaging gets quite muddled and people are misunderstanding what AI really is. One thing I've always said was AI, if we actually have a real AI, we have Skynet, and I want to be very afraid of that.
Let's watch out for Skynet. Skynet, not good. Hopefully we have people old enough on this call to know what Skynet is. Florian, why don't you fill us in on the less sinister side of this practice and give us a little picture around some of the benefits that we can derive from practices like machine learning, data science, computer vision?
Yeah, sure. Maybe also a word about the history. I mean, the field of AI has been around for a long time. We have been talking about that in the 40s, 50s, 60s, and somehow it's always encompassing new technology. I mean, when the first chatbots were out, we also called them AI. So the newest wave about machine learning and deep learning, I mean, there's a very good reason why this is popular right now, because we found new ways to do it that actually seem to work very well. it's still no magic cure that like solves everything. But in 2012 and afterwards, there were publications that made things work much better than before. And in my specific field in video analytics, we actually use mostly, not exclusively, but mostly a subset of machine learning, which is deep learning, where we try to train networks, deep learning networks in the lab to detect certain things, to detect certain objects in the video, and so on. And that has huge applications. One of the things I'm always dealing with is not only is AI a huge hype, but the impression is that nowadays systems only work with AI, and that's not the case, or machine learning or deep learning. It's one technology that helps you achieve a certain outcome. And it is a technology, it's a set of methods, it's a set of algorithms that work great, but it always depends on the applications, and you need to think about what you want to do with it, what you can achieve with it. And machine learning or deep learning or AI by itself it's just a set of methods. It's no outcome.
I will, if I may, add one more thing. Not to take the alarmist approach again, but one thing that also is being misconstrued often is that it's all 100% accurate. Very, very rarely do you even see 95% accuracy in a lot of these things, and it depends on the application. So that's something we always want to have our customers ask is, what will this do in a real environment? What are the performance guarantees I can, measure upon and actually expect when I'm going to use this in reality? Because things like cardholder presented their badge, the cardholder is a known thing and doesn't change, and we can say, yes, that is that badge, and grant their access. We start doing things that are more advanced and using these AI techniques, whatever you may want to call them, we may see those accuracies drop. And what do we do in that case? Do we still grant access? Do we not? We need to understand what that's going to do. So there's a lot of knowledge that needs to be transferred on with these that, we're happy to participate in that conversation and dialogue.
And to me, it's sounding like it's a part of a larger ecosystem, and it helps that ecosystem of technology that we're bringing to the end user, but it's not the end in itself. Is that a correct estimation? Okay, so let's talk a little bit then, at the top of the chat here, could we talk a little bit about how we integrate our practice of developing things like machine learning, deep learning, computer vision? How are we integrating that into the offering of a unified physical security platform? And I'll toss that over to you, Florian. You can kick it off, and Sean, chime in.
Yeah, sure. So on the video analytics side, we create separate modules that plug into your existing security center system. They're actually already part of Security Center. So when you install Security Center, it's already in there. It's just activated with a license. It's a product portfolio that we call Kiwi Vision. So this is how we integrate these technologies into our product, into our video analytics solutions. But in general, the goal is that we try to find areas where it really makes sense to automate things in your Security Center system, in your video management system, in our case, for video analytics. So video analytics in general is always the idea of trying to figure out what's happening in the video, trying to structure the video information, which by itself is unstructured. So we don't know what's happening in there. Video analytics tries to figure out what's happening in the video. And we're trying to find areas or applications where we can automate stuff using video analytics. And it ranges from tampering detection to people counting to many, many other things. And for some things, we think, well, it makes more sense that our tech partners are doing it, who are doing a great job. And for other things, we think, okay, well, it's really core technology that should be in the core where it really brings a lot of value to our users.
Absolutely. We're going to come back to the importance of the overall Genetec ecosystem with our technology partners. But Shauna, Florian made a mention of it in this discussion, and he said, it's an automation aspect in the product. And I think, I'm not going to steal your thunder, but maybe you could talk a little bit about a concept much beloved of someone we both know, the idea of intelligent automation.
Yeah, so these types of techniques that we're applying for machine learning are extracting advanced knowledge from raw text. Like for Florian and video analytics example, there's always a ton of information in unstructured video. It's very computationally expensive to extract it, so it costs a lot of money in both server hardware, compute, licensing, usually depending on who you purchase and everything, to extract that knowledge. Then what do you do with it? So you can say, I have detected faces in this video. Who are they of? What do I want to do with them? That requires automation now. Like when a face is detected, what do I do? Either rules-based automation, which we are at Genetec also working on, or something more advanced, where then you start layering machine learning applications together. For example, Kiwi, I know, is coming up with a crowd detector. So measuring the live volume of people in a space. That, to my group, looks like a stream of information saying there are 20 people, now there's 40 people, now there's 60 people, back down, and it's a kind of ever-evolving measure. From that, we can do things like anomaly detection, looking at, okay, it's a Saturday, the normal crowd volume at this time of day is between 60 and 80 people, and it varies a little bit, but all of a sudden it swells to 200. So what do we do with that? Then we can raise an alarm, bring an operator, maybe there's a protest forming that they need security at, or let's have great applications for like college campuses. But that only works when there's two solutions working together, and we do this automation in layers. We have to first extract the crowd information and then build knowledge on top of that. Where you can make these layers as deep as you want, and there can be solution on top of solution, but it all is really done for domain-specific problems. You have to know what you're trying to solve and what you want to get out of it before you start tackling it. The misconception that these AI solutions will just solve my problems. What's your problem? Is always the question we have to ask first.
Absolutely. I think it's a challenge to get people to articulate that, and that is kind of why these sort of advertising slogans like just add AI, it's going to solve whatever you dream up. Florian, I want to come over to you related to a note that Sean brought up, this idea of layering and stacking things. Do you think Genetec has always made such a point of emphasizing the idea of a unified platform? Do you think that offers a unique advantage for data science professionals such as yourself to really develop deep layers within a single sort of platform?
Absolutely, and I think by combining different data you have available, that's where you create true insights. And yes, we have been always talking about unification, and it's more important than ever, to be honest. But if you look at traditional systems in the market where you have a separate VMS, you have a separate access control system, separate license plate recognition systems, they're all silos, and maybe you combine them in a PSIM somehow by accessing them on demand, but the data is not available. But since we have a unified system, we have access to all of this data. We have access to access control data, to video streams, to motion detection data, even to data coming from the cameras. Cameras are streaming nowadays lots of metadata into our system. And this provides unique opportunities to find correlation between these data points. And this is just starting today. This will be hugely important in the coming years, in 5 to 10 years from now. And going back to video analytics, if we look at all the data that's coming in through our unified systems, as Sean mentioned, an access control event when somebody badges in is a quite true and very determined data point. So this person accessed with this card, this door. So there is no uncertainty of that. So this is very structured data. But when we record video, the only thing we know is we received the video stream from this camera at this point in time, maybe this resolution, and that's it. So it's unstructured. We cannot search through it. We cannot use this data. And this is what we're doing in video analytics. We're creating the metadata layer to figure out what's happening in the video. So on a layer on top of it, the data science group can create insights out of that to say, we have metadata from this camera where this happened, and at the same time, something in access control happened, and correlate this data. So this concept of layering is very important, where for video, we are in the beginning to structure the video and create metadata out of that.
That's a great point, and that really is one of the true values of this unified stack. I guess one of the questions then comes is, and Sean, you talked a little bit about, providing better alarms to operators. Can you expand a little bit, beyond sort of alarm and situational awareness to some of the benefits you see for this this sort of layering and bringing structure to unstructured data within the Genetec platform?
Sure. So just as an example, and I find this is a helpful one, we actually have a prototype that we worked on, combining LPR and access control together. So not the actual camera photo, converting it to the characters of a license plate, but the metadata collected by Security Center after. Little backstory, and this is a funny one, is from our CEO, who was noticing from his office that people who don't work at Genetec were parking in our parking lot and working across the street. I know, shock.
Scandal.
So he wanted to see if we could identify who are Genetec employees, and if we could identify over time whose cars or possibly belongs to which card holder, to identify which cars are actually authorized to park in our lot. We have no gates. We have no registry of people's cars that were built in advance, but it helped automate. What we came up with is a solution that you can, over time, build a confidence interval on what you think, whose car belongs to which card holders, and are these people carpool because they all kind of badge in around the same time, but there's only one car seen coming in, or do they take public transit, stuff like that. But it helped us identify a few outliers that were people that we were taking parking spots that we do actually pay for. So it was making it harder for Genetec employees. So that's just one way to help parking management, and it unfortunately didn't involve video analytics, but it was a neat solution that was able to be combined, two things that Genetec does internally very well, access control and LPR, and be able to bring an additional stream of information that then can be leveraged by operations, security, whatever down the road.
So it's making inferences out of two separate data streams that are within the unified stack, and sort of saying, okay, here's our best guess about, because we don't give our license plate numbers to the facilities team, right?
Right. Yeah, and I mean, we can do things like with all sorts of video metadata as well. We have a few projects that didn't pan out quite as well as we'd hoped, but trying to estimate which cameras might be physically near each other. So if you have a very large system, organization of your cameras next to each other in some type of visual tree is kind of the only way anyone does it these days. But one thing that could be really helpful is figuring out which cameras are actually near each other. So when an event occurs, I could automatically pull up those. And what we were looking at was motion patterns. So when this camera has motion, these other three also have motion around the same time, and that occurs over an extended period. Like every day, they might all be entrances to office buildings. So then that's a similar thing I want to look up. It turned out to be much more difficult than we thought, but it was an interesting research topic. We tried it out. We did have some success, but it's a little inaccurate to use in a real world application. And that's something that happens a lot in these industries. We'll try a lot of stuff, trying to bring additional value and solutions. And maybe one day, if there's more metadata that we can leverage that'll make it more accurate, then we'll see it come to market. But right now, it's a fun research topic that we got to spend some time on.
Well, I would, and I'm going to bring it to you, Florian, but I mean, it is it's about small increments and refining and making things better. It's not about, big eureka moments. Hopefully maybe there will be, but, I want to go to you, Florian. Like when we talk about things like computer vision, like algorithms that are, driving computer vision, how do you, approach that within your practice in the analytics group? How do you leverage data science, machine learning to improve the performance of analytics? How do you pull that all together?
We have all these terms. We have computer vision and machine learning and AI, and it's always hard to explain it in an easy way, because in practice, computer vision is a separate field that uses separate different methods, and one of these methods is machine learning or deep learning. And the way we use it today is our people counting is a very good example, where traditionally we did people counting based on detecting motion in the image, figuring out if those are people, tracking these people, and then counting if they cross the line. So that's the traditional approach. But it's very challenging in a lot of situations where you have different lighting, where you have shadows and so on, where there are a bunch of people in there. So some time ago, we switched the approach completely to detecting people with deep learning. And that means that we get hundreds of thousands of images of people, for example, top down, but also looking from the side. And we annotate this data set. So we actually have physically people sitting there, and for each individual image, saying this is a person there in the video or there in the video, essentially drawing boxes around people. So it's a very tedious task, but it's one thing that you need. You need a data set, and this data set is super important for parts of machine learning. So we did that for, initially it was 500,000 images, but now it's much more. And we use this data where it tells you for every person, this is a person or this is not a person, to train a model. And so we put it in the algorithm, and it automatically learns how a person looks like in the image. And today, we very successfully apply that in our people counting, where in the people counting, we use deep learning to detect what are people in the image. And everything else is ignored. So we ignore shadows, we ignore highlights, anything else, and that enables us to drive up the accuracy to really numbers that haven't been seen before in this industry. And that's an application where we really see how machine learning makes a huge difference to the end customer, to the user, by increasing the accuracy. And at the same time, we decrease the speed or the time it takes to configure the analytics by 3 times. So configuration times is 3 times faster, and accuracy is dramatically higher than before.
And right now, accuracy is like, such an important thing when you look at retailers who are leveraging people counting to know how many people are actually in their facilities at any time. Is that something that your analytics are being used for right now, Florian?
Absolutely. So one of the hugely valuable and also successful things during the pandemic was the occupancy management package that we introduced. It's a new package by Genetec that allows retailers, or really any business that tries to reopen after COVID or during COVID, to measure how many people are in the facility. So you use people counting, employing machine learning, to figure out how many people go in, how many people go out, and based on this number, we know how many people are in the store right now. And based on this number, we can trigger certain actions. We can switch a light to red at the entrance. We can trigger an audio message. We can send an event to an operator. So many things. And this has really shown to be very, very helpful for businesses to reopen.
That's great. Sean, bringing it over to you in terms of what Florian was talking about, around development and training, and this idea of having to train, your system, or for lack of a better word. I know one of your colleagues in Montreal, Dr. Brodeur, she's done a lot of work in terms of the ALPR engine and sort of the performance there. Can you talk a little bit about how we train systems and why training is so important?
Sure. So it's gotten more and more important in deep learning because there's so many parameters inside of it internally. They're usually layers on layers on layers, not of machine learning solutions, but think of a human brain. There's a lot of neurons that pass messages to more neurons, that pass messages to more neurons, and down and down and down. Deep neural networks are modeled off this technically. So there's like a little node, actually called a neuron, that passes messages along to all the other nodes in the next layer. Now, deep learning comes from having many layers, a deep neural network. Because of this, there can be thousands, if not many more parameters to tune. In order tune them accurately, you need a lot of examples. And especially in AutoView, our ALPR solution, they've done some really neat things where they'll take one image and generate 1,000 samples from it by cropping the image at different places. So like we know there's a license plate that's ABC123, but we're only going to show the algorithm this piece of it and still say it's ABC123, or we're going to rotate it, or we're going to flip it in reverse, or whatever. And that creates a lot of additional examples. So that's one trick, but you still need a lot of samples. And I mean, real accuracy in big neural networks is millions of examples. For other solutions, that's not necessarily always the case. In a lot of the stuff I do, which is called unsupervised learning, we actually don't know any truth. We don't know, in the lingo, it's called ground truth, which is, this is the actual value or information in your data record. From that is how you do training, because when the algorithm guesses incorrectly, you go back and make tiny adjustments saying, well, okay, yes, you were wrong by this much in this direction, and adjust. So the next time you're closer, and you do this over and over and over and over and over. That's how you train using supervised data. In unsupervised learning, we have no idea. It's a stream of information that we don't know necessarily even what it's related to. So if you think of like network volume, and people connecting, disconnecting, and stuff. So you say, this is the number of people connected at any time. What's correct? There isn't one. There's just a value. It's a high, low, whatever. And one thing that you could do would be to say, when is it abnormally high? So over time, you can kind of figure out what that stream looks like and what that data is normally. And then when it spikes away by a statistical amount, then we can say, oh, that's abnormal. That's kind of one of the limitations when you're dealing with unsupervised data. It's usually a very complicated research field, and it definitely hasn't seen quite the gains that deep learning has, unfortunately, in these later years. But we're hoping it picks up, and there's a lot of value there because it doesn't require, this very tedious and expensive process of labeling data. I know just in our ANPR solution, they have used to be 3 labelers who were like part-time staff that would have to come in and literally just sit there saying, well, here's a license plate in the image, it's A, B, C, 1, 2, 3, and they do this thousands and thousands of times a day. So that we can get
free coffee at Genetec. Free coffee. Definitely over in that building. Florian, go jump in. You were trying to jump in.
Yeah, right. I just wanted to add one point regarding data sets and to stress how important that is. Because having had a startup, I can tell you, if you start a startup nowadays, one of the big issues you have is you don't have any data. So where do you get the data from to train your system? And the only thing really you can do is you can take public data sets, usually, and that's the gray area because usually they are meant for only research purposes and not commercial purposes. So you have a legal challenge there. Or you take some pre-trained models, but then you don't have any advantage towards other players in the market. So data sets are hugely important, and we're so lucky as Genetec and uniquely positioned that we have been in this market for 20 years. So we had the time to build up data sets to work in certain industries, and ALPR is a very good example where AutoView has been around for I think 12, 14 years, and that is a long time where you take license plates from different areas in the world, where you have time to annotate them and so on, and build this data set. And these data sets are the gold of tomorrow. And really, in our space, there are few companies in the market that can really say that they had the ability to build up this data set.
And I think there's maybe even a little bit of a controversial aspect to this, and I'll put it out to both of you, but I think in our industry specifically, there are some, I don't know, some vendors, some manufacturers who maybe are acquiring data sets that are not coming from really great places. Can you talk a little bit about that, Florian, and the sort of ethical concerns?
Yeah, so actually, yes, you're mentioning the third option that you have as a startup. You can buy data sets from China that are not coming from very ethical places. So usually people do not give their consent to be recorded They do not know what's happening with their data. And these data sets are around and are being traded around, and you can pay money for it. And of course, it's not something we're doing. We are really super accurate and ethical there because we have an ethical responsibility to protect the privacy of people that are being recorded. And again, it's a challenge in our industry for AI and for deep learning. How do you balance only using data from people who really gave their okay to do it and to protect their privacy, while at the same time building up data sets? And incidentally, this is part of a discussion in the European Commission right now to establish new guidelines for AI and privacy.
Yeah, that's go ahead, Sean.
So yeah, I will admit that my side of the world, my side of data science is definitely a little luckier in that, because we can apply something called anonymization. Usually it's much easier to do on metadata than trying to anonymize raw video. By deleting information from video, you're probably going to really screw with the algorithm and make it much less accurate, or not really able to interpret what it comes out with. Whereas for us, if we do a one-way conversion of all the license plates in a data set to just a random string, as long as when the same string, the same license plate ABC123 was seen and converted to the same value on the other end, we can't go backwards. So we can't recover the original data, but it gives us the same value when we're training a model going forward. So anonymization is one trick that we can do that does keep our customers' data safe. The other one, which I have been involved in the past, is actually doing the training on site at a customer's location so that nothing even leaves their environment. The model that ends up coming out has no customer information in it. It's just statistical parameters of data. So there's nothing you can reverse engineer from it and get back to the original data set. And we've studied stuff like k-anonymity problems, where how many data points of loosely informational data do you need in order to rebuild a person's information? So for example, you have an ID that links to a name, but then you have an access event that links to the ID. And from that, you have the license plate that links to the access event. So how many degrees of separation, and where can you break that chain in order to guarantee a user's safety so that it doesn't link to their name? What some things we do within Security Center is that name is only resolved from its ID at runtime. So like when someone actually runs a report, if that name is in the system, then it's resolved. Otherwise, if that person's deleted because they did in Europe a GDPR request, for example, and said, I don't want to be in this anymore, please remove me, all that's left is an ID. Because we also have to be careful on the other side that when we delete personal information, we're not mutating legal records. So things like, this entity was deleted in the system, or someone modified a camera. If all of a sudden we deleted the whole information around that occurring, then there'd be an audit trail issue, and you could get into some legal challenges on the other side. So we have this delicate balance in the middle of maintaining privacy as well as maintaining, auditability. Yeah,
chain of custody becomes so important. Sorry, Florian, go ahead.
No, I was just smiling.
Oh, you're just smiling. Well, that's wonderful. I'm glad you're smiling.
I sometimes do that.
Good job. So, as a marketer, guys, I keep an eye on what's going on in the industry, and I see a lot of videos and promotional brochures and stuff like that, advertising on the interwebs. There's a lot of faces in bounding boxes and people walking around with little numbers under them, and it's very like Hollywood, right? It's like CSI or 24 with Jack Bauer. Again, maybe they didn't have it way back with 24, but it's like very CSI. Is this really the value of it, that you see these bounding boxes? I think people are getting confused. Florian, can you talk a little bit about what truly analytics are bringing to this? And maybe this is a little bit of a replay of earlier, but I think it's worth restating.
Yeah, sure. One story I always tell when I talk to people about our video analytics is that when I started off in the industry 15 years ago or 19 years ago, the market had an expectation of things that you see in CSI, and yes, 24 was still a thing back then. And the expectation was maybe like this, like where's the video here, really large, right? And what back then video analytics could deliver was super small, super small subset of what people were actually expecting. And that was a big challenge back then to explain to people that this is what it can actually do. And that's why so many things were promised and not kept in these days. And nowadays, we still have the same expectation, or you would even say it's larger. And nowadays, we can solve a much bigger subset. So maybe like this, but it's still a subset of the expectations that people have. And that's why it's so important to talk in the market about it's not AI, it's machine learning and many other things, and explain to people what it actually does. So where it provides value is detecting some things like objects much more accurately than before, counting people much more accurately, just increasing the accuracy of existing video analytics applications. It doesn't bring so many new applications in video analytics because many things on the use case perspective were there before. Now you can just make them work much better than before with less configuration time and higher accuracy. People counting being one of them, tampering detection on cameras is one of them. Or as Sean spoiled my thunder before, we are working on crowd estimation. We don't like to talk so much about things that are happening in R&D because we don't know exactly how the outcome will look like. But what we are working on is using machine learning or deep learning to detect how many people are in a given area in a camera right now. So without counting in and out, we can tell you how many people are in an area, and that opens up so many more applications just beyond stores to reopen up after COVID. You can use it for transit to know how many people are on the platform. You can use it then in airports to know how many people are waiting at the gate. You can use it in an office environment, like spatial analytics in office will be a huge thing to know where are people in the office, how are cafeterias being utilized, and so on. So this is something that's in R&D right now. It's not close to be released yet, but this will be a big thing and a hugely valuable contribution of machine learning to the industry.
So to that point, gentlemen, talking about machine learning and the contribution to the industry, let's talk a little bit more about the contribution to society right now during the pandemic. We've talked a lot about the value that we can derive from bringing structure to unstructured data. We talked about occupancy management. Can you guys talk a little bit more about how machine learning is driving, and it doesn't even have to necessarily be related to a Genetec solution, but how it's driving value during the pandemic period? And then from value, I mean public safety, individual safety, getting people back to work in a more secure way. Sean, why don't you take a kick at that to start with?
Sure. So there are some interesting applications in not just data science, but just general like app development, really, related to, for lack of a better word, tracking COVID patients and helping do contact tracing. So Canada actually, I know, is promoting one. I have it, I admit, on my phone that will randomly transmit, or it generates a random ID for your phone. When you come in contact with another phone, over Bluetooth, they exchange these IDs. So over time, you build up a wealth of information as I was near these random IDs at this time. From that, if anyone in that set that you were near says, I tested positive for COVID, then it notifies everyone in a set time window and near them who was at that time to say, you should probably go get tested. You came in contact with someone with COVID. Thankfully, mine hasn't gone off. But that I find is a really good use of it because they're not doing, which we have seen also on the other side, is fully tracking people's locations. Yeah. Those may be built with the right intentions, but there's a big risk that they'll be misused after the pandemic's over, especially. That data is being collected, stored somewhere. Who owns it is sometimes not super clear. The company that built it very quickly for the pandemic to try and capitalize on a market need, which, they may have done well financially from, but, do they have a long history of ethical decisions with data management? Are they going to sell that to advertisers down the road? We don't know. Whereas in this case, I did read about it before I installed it. And in this case, there's very little they could sell. Even if they did sell all of those Bluetooth addresses, they could say you came in contact with this other random ID that was randomly generated by this app. It actually doesn't even link to your Bluetooth or your phone, or I said an identifier you could reverse engineer. So at that point, I accepted it as an acceptable risk in order to help mitigate COVID and do my part.
Yeah, it's a really cool application, just in terms of a privacy perspective. Florian, what about you? Where do you see, this practice adding societal value right now?
So, I mean, tons of applications. I mentioned a few before. One of the more interesting ones I find is that so many analytics companies are coming out with a social distancing analytic. So something that tells you if people walk too close to each other. And it's great. It's a great first step. But when you actually apply it, you have the issue. What do you do with the data? So how do you act upon it? Where things like our mission control become crucial, where you have standard operating procedures where you can act upon this information. Or do you not act upon it right now, but use it as a statistical measure to know are people crowding around my city? And I recently had a very interesting conversation with a researcher from the University of Amsterdam. And she's actually a sociologist and a criminologist. And she's working with the police there, where she's applying these type of video analytics to automatically detect when people are walking close to each other. But what the police found is that this data is not so valuable because people from the same household are allowed to walk next to each other, and no analytic can actually figure that out if they belong to each other or not. So what they do is they collect this information, and the sociologist and criminologist is analyzing this data afterwards to verify who belongs together or not. And this is based on some social clues, like are people holding hands or are they talking to each other? And then she knows they belong together and she takes it out of the data set. And the police every week get a cleaned up data set where they know in which part of the city people have been actually crowding, meaning people that are not supposed to be together, that are not living in the same household. And I find it a beautiful example how you can actually provide real world use cases with technology, but also that technology is not the be all end all to the whole thing, and you need to combine it with human intelligence to really make it valuable.
Yeah, and that comes to that whole training and the role of humans in this, right? It's not some robot you just point in the right direction and magically get results. It was funny, Florian, you answered a question from our audience who asked that very question about social distancing as just before you started talking. So it's like you were joined up. So I hope the audience member who asked that got the answer. And we've had some other questions around how we might be leveraging machine learning, not just in this period, but more broadly, to sort of bring back business. And Sean, maybe you can talk to some of the interesting aspects of how, the practice that you're in charge of at Genetec is seeing ways to actually take a business approach to, recovery, things around supply chain and modeling. Can you talk a little bit about that?
Sure. So in this industry, it's not unique. There is a supply chain. We have not a lot of hardware options that we do manufacture and deliver, but we do have some. And because of that, we have to source the components, assemble them, and there's a whole chain. During this pandemic, we've had interruptions, as well as many, many other companies. And we're seeing some interesting research topics in supply chain modeling that have finally, after 20 years of being stale and stagnant, seeing some recovery, because now companies need to say, okay, I need to look at alternate supply sources, stuff that I've never even considered before. Maybe there are routes that are faster in order to meet my customers' needs. We haven't started on that per se in my group, but we have seen some research come out that is showing that there's been a lot of enhanced involvement in that. We also, though, are working with our sales team doing some business case modeling, and internally we do a lot of performance health modeling. So instead of buying a new system, we can help you keep the maintenance on your old one down to a minimum. So we'll collect things like, with obviously customers' approval and when they request it, their performance health data relating to CPU, memory, process usage, logs from Genetec server, stuff like that. And then we run a quite large anomaly detection pipeline across all of the servers in your environment in order to say, is anything stable, is anything unstable? It has helped us find root cause for some failures in some systems, but also going forward, we'd like to start using it for sort of predictive health in order to say, your system's stable, but if you do these parameter tunings, we can see an improvement in performance, and then you'll get an expanded lifetime, or you'll just see it work faster, which is always a win for both sides.
Absolutely. So it's sort of like something that will bring value to our partners on the integration side, and of course also our end users in terms of their experience of the Security Center platform. All right, gentlemen, we're coming to the end of our time together. So I have two last questions, and they're more, put on your advice caps and then your imagination cap. So the first one is the advice cap. What would be your recommendations to a security professional, whether an integrator or an end user working for a company or government or a city, as they start considering leveraging the various tributaries of artificial intelligence in their practice if they've never done it before? Florian, what's your advice to this person?
So my advice would be not to focus on the technology. So not focus on, does this have AI or machine learning, but look at your use case and the application, and if it makes sense for you. So does the product offer the output that you can leverage and that you can use? You shouldn't really care so much how it works under the hood. We only talk about AI because it's great to talk about it in marketing. But the same way we don't talk about programming languages, you shouldn't care about how it's done. You should care about the output. And if you're not sure about the output, try it out. Do trial runs, POCs, and just see if it does what you are hoping to do. And think about your problem and then see if we can solve it.
Okay, focus on outcomes. All right, Sean, what's your advice?
So in a complement to that, I would say when you're looking at vendors, this is always my biggest piece of advice, is really ask, what is the accuracy in a real environment? We found that there's a lot of promises out there, and when you actually deploy it, not in a lab scenario where the numbers might have been collected in the first place, what are the accuracies going to be? Because that's also something, if you find the solution that you think will solve your business case, but it only gives you the right answer 80% of the time, what do you do in the remaining 20%? Or 95%? There's still a 5% outlier that you need to account for. You need to be aware of that going in advance, that when this exception scenario occurs, what do you do as an action? Because if you aren't prepared for that and you assume it's going to be 100% accurate all the time, the first mistake it makes, you'll never trust it again. Mm-hmm. And you'll have done all this investment and research and everything for naught. So just being an informed buyer when you're going in, and the vendor should be happy to give this information to you. We always are, and we'll set up a POC and work through it so you can try it out and get a feel for what it'll be like in a real world scenario.
That's a very good. So have a smart and sort of cautiously optimistic view. Don't just put all of your faith into the technology. Okay, for the last question, I want to put out to you. Where do you see the future of this leading, the future of the type of technology and research that you're both working on? where do you see it taking the industry, the security industry, in the next 5 years? So sort of give us a little bit of a look ahead on what you gentlemen are thinking. And Florian, why don't you kick us off?
Sure. So it will become more and more ubiquitous. In the future, it will be all about data. I find it funny when I still see tenders where companies want to buy a video analytics system. You shouldn't talk about buying 100 channels of video analytics. You should focus on buying outcomes. You want to do that. You want to detect that, and you need to buy a system that provides it. So this technology will grow more and more into the core components of all these systems in our industry. And video analytics is just one data provider to many data providers. And it will be much more about the data in the future and how to make sense of this data. So the layering that we talked about before will be super important. And not necessarily the same players will do all the data management as they are doing today. So we might be doing it, others might be doing it, and others might not be doing it. But I think it will be extremely important for end users to have this insight into their data, because data is growing, we all know it, and we all need to handle it somehow.
Right. Data as the future and outcomes again. Sean.
Yeah, so again, a good complement to that. I think what we're going to see coming forward is, yes, that all these analytics are going to be more and more ubiquitous, but a question that we get all the time is, I want to see these 3 things you've built with my ERP system, with my building automation system, with, well, I can't even think of any more right now, but every time a customer says, this is great, but I need more data that you don't have. So seeing these integration points and being able to combine that together means someone's going to have to be a general platform to route and manage data so that it can be leveraged together, because all these outcomes really often come from when you combine it with an external system. And we've seen some companies who have threat modeling systems. They want to see their video with the threat model, or their access control events with the threat model, and feeding into the threat model, having the threat model feed back into alarms. These bi-directional integrations are going to be more and more necessary and shouldn't be PSIMs. They should be built through flexible frameworks so that customers, one vendor can produce their solution, and there can be lightweight integrations to connect them together, not these heavy duty things that you require a ton of custom work. But every customer's environment is different, so they often have purchased different vendors together. Now, Genetec is lucky to have a really good wealth of integrations already. We're going to see that grow, I think, going forward significantly, so that you can combine the data we provide with a lot of other things out there and bring better outcomes overall.
So it's about being a good player in a broader and growing ecosystem rather than building hard connections between technologies.
Because then once you have all that access, then you can really leverage it. So my team we can start looking at, you have an ERP system, and employees are doing this kind of information. Do you want to put anomaly detection on top of that? We have the core logic, and you feed in the data, we can process it and give you back out results that you could feed back somewhere else. So you can start leveraging the pieces that we do manufacture with systems that we've never seen or touched before.
That's really amazing. So starting to look more broadly within your organizations, cities, governments, enterprises, to bring value across different, not just security endpoints. So, very interesting. Well, gentlemen, this was a wonderful way to wrap up the Innovate Everyday seminar series of this summer. I want to thank both of you for taking time out of your busy schedules to come join us here. I know the audience, given the number of questions we've had, and thank you very much, have appreciated the time we've spent together. And to our audience, thank you for coming and joining us. If this is just your first Innovate Everyday or you've joined us for all 5 seminars, thank you for coming. All of these seminars are going to be available immediately on demand. So if you or your colleague didn't make it, but you registered, you'll get a link to the videos, and we'll be putting these videos on our website in the fall. So we're very excited to share the wealth of knowledge from these great panelists with our audience. So this is me signing off, Andrew Elvish. Thank you for joining us. Thank you, gentlemen, and have a good rest of your day, everyone. Goodbye.
Bye, everyone.
Yeah.